Right, so let's go through the June exam. Those questions answered very well. Determine the value of I to the power of 7. Oh, let's look that. I to the power of 2007 is equal to, we want a power of 4, so I've got I to the power of 2004 times by I squared times by I. Now we know that anything to the power of 4 is going to give us 1, and I squared is -1, and then we want our I to stay as an I. So we end up with negative I. Now mark allocations. You get 1 method mark, and you get 1 mark for accuracy. We did give you the marks in this case, even if you went straight to your calculator. All right, let's look at the next one. Our next question is factorize x squared minus 4x plus 5 using complex factors. So obviously we want to start by completing the square. So you've got your x squared minus 4x plus 5. And we're going to complete the square. So we've got x minus 2 squared plus 1. Turn that into a difference of 2 squares, which becomes x minus 2 minus the square root of -1, and x minus 2 plus the square root of -1. Obviously we don't want that root -1, we want an I, so you've got x minus 2 minus I, x minus 2 plus I. I haven't put in every single step there, but your marks are for using the correct method and getting it accurate. And then you get a mark, an accuracy mark for that bracket and that bracket. The reason why we don't see A is because you can check this directly using your silver calculator. All right, let's have a look at the next one. So here we have using the complex numbers, and you've got your complex numbers Z and W. You're going to determine 2W plus Z, which in this case we just substitute what W is and what Z is. So you've got 2 times 3 minus I plus our Z is -2 plus 2I. What you need to remember to do here is to distribute into your brackets. So you've got 6 minus 2I minus 2 plus 2I. Simplify that, your -2I and 2I becomes 0, so 6 minus 2 is 4. And you could have used your calculator. You're going to get accuracy mark for substituting and then a CA mark. If you use your calculator, you do get your 4 marks because we didn't say without a calculator. And let's have a look at our last question now. We've got Z times I cubed, and again, you're going to substitute in place of Z, you've got -2 plus 2I, and you multiply that by I cubed. Times that in, you've got -2I cubed, and you've got plus 2I to the power of 4, which becomes 2I plus 2, because of what I squared is. And you can check that directly with your calculator. You get an accuracy mark for your substitution at the beginning, and then you've got CA marks. All right, let's have a look at question 2. Now in this question it says, decompose the following fraction into its partial fractions. This was work from last year, and I was very impressed by the way that most people could actually recall that from last year. Okay, remember your first step when you're decomposing into partial fractions is to split up based on your denominator. So you know that you're going to have a denominator of x minus 2 as one of your denominators. So we're going to put an a, because we're eventually going to solve for a, plus b over one of your other denominators would have to be an x plus 1, and then because it's squared, one of your other denominators would have to have been x plus 1 squared. Do it in a different order. I know a few of you did, but I did it in this order. Then we times everything by the LCD. And in doing so, we've now got 4x squared plus 3x plus 5 is equal to a times by whatever was missing when we actually multiplied by the LCD. So that's x plus 1 squared plus b. What's missing in that denominator is we've got our x minus 2, and we've got our x plus 1 plus c. What's missing there is the x minus 2. Now, many of you use the other method, which is a little bit longer, but I use the method here where you let x be specific values that make your bracket 0. So we're going to start by saying let x be equal to -1, because then the bracket that has x plus 1 will be 0. So if we do that, we're going to be eliminating certain brackets that have the x plus 1, and all that we're left with is the last bracket, and we've replaced x with -1 in the 4x squared plus 3x plus 5. If we do that, we get 6. And then we look at the only bracket that doesn't have an x plus 1 in, and that's our last one. If we sub x to be -1, we get -3, and we've got -3c. Solve that, and we get -2 to be equal to c. Now I need to also go and let x be equal to 2, so that I can eliminate the bracket that has an x minus 2 in it. Again, I substitute 2 in place of the x's with the 4x squared plus 3x plus 5. In that case, I get 27. Then I have the bracket where I have a times x plus 1 squared. I make my x to be 2. So I get 3 squared, which is 9, and I've got my a. Divide both sides by 9. So my a is 3. Last one, I'm going to let x be equal to 0. Because in doing so, I now have an equation that will have an a, a b, and a c in. And by doing that, I can now solve. Okay, so if I let x be equal to 0, I eliminate that 4x squared and 3x, and I'm left with 5. Then I'm left with a times by 0 plus 1 squared, which is just a, minus, if I substitute in that second term, I'm going to get 2, and then it's times by b, minus 2c. Yeah, but of course I know what my a and my c are, so if I let my a be 3 and my c be -2, I'm going to land up with having 2b is equal to 2, and left with b is equal to 1. So just to finish it off, I've got that 4x squared plus 3x plus 5 over x minus 2, x plus 1 squared is equal to 3 over x minus 2 plus 1 over x plus 1 minus 2 over x plus 1 squared. Let's have a look at mark allocations in this question. At the beginning, you've got a mark for using the correct method, and then you get an accuracy mark as well. You get a method mark for letting x be equal to those different values, or if you're using another method, you'll get a method mark there. And then you're going to get a CA, CA, and a CA mark. To give you a total of 7 marks.